Welcome again, my esteemed viewers and also my students. We are going to look at this question on linear inequalities. Linear inequalities. So, draw the regions which satisfy all the inequalities. So, we have the first inequality, 3x plus 2y is greater than 4. The second inequality, 2x minus 2y is less or equal to 5. And the third one is y is less than or equal to 4. So we have the three inequalities and we need to represent it on a graph. So I'll work it out, then I will show you how to represent those regions on this graph book. Fine. So before even we draw it, we need first to know the linear equation that we are going to draw. I'm going to start with the first one, then the second, and then the third one. So the first one, allow me to rewrite those equations in the form of y is equal to mx plus a constant. So the first one, which is 3x plus 2y is, let me use the equal sign, is equal to 4. But later when we draw, we have to identify which region satisfy the inequality. So this will be 2y. Subtract 3x on both sides, so 2y will be equal to minus 3x plus 4. So we divide each term by 2, so we shall get y by 2 1 by 2 1, so y will be equal to minus 3 over 2 x plus 4 divided by 2 is 2. So we need to make a table for the corresponding values of x and y, which will enable us to plot points, and then we identify the region represented by this inequality. So we can take points near the origin, as we can have, since the coefficient of x here has a fraction which is 2, let us choose values of which x which are divisible by 2. So I can take minus 2, I take 0 and 2. So then we substitute the values of x into the equation to get the corresponding values of y. So in this case, so when x is minus 2, we substitute it here. So we have minus 3 over 2, x is minus 2, then plus 2. So we get the value of y by 2 1 by 2 minus 1. So minus 3 times minus 1, that is 3, then plus 2, y is 5. When x is 0, substitute here, minus 3 over 2 times 0, that is 0 plus 2, we have 2. When x is 2, so minus 3 over 2 times 2 plus 2, so by 2 1 by 2 1, so minus 3 plus 2, so we have minus 1. So this one value or table that we are going to use to help us plot on the graph. Then we have the second one, so that is the first. The second one, we have 2x minus 2y is less or equal to 5. So let me take equal sign equal to 5. So let me rewrite it again in the form of y is equals to mx plus a constant. So I will have, let us subtract 2x on both sides. So I will have minus 2y will be equal to minus 2x plus 5. Divide each term by minus 2, divide by minus 2, divide by minus 2. So by minus 2 1 by minus 2 1, so we have y is equal to This will be minus by minus 2, 1 by minus 2, 1. So we have x, then minus 5 over 2, that is minus 2.5. So again, for this, let us make a corresponding value, a table for the corresponding values of x and y. Again, we take points near the origin. I can take minus 3, I can take 0, and again I can take 2. So minus 3, when x is minus 3, what will be y? So minus 3 minus 2.5, that will be minus 5.5. Then 0 minus 2.5, that will be minus 2.5. And then 2 minus 2.5, that will be minus 0.5. So this again will help us when it comes to now drawing the graph. And lastly, we have the third inequality, which is, now we are going to draw the line y is equal to 4, bearing in mind the inequality symbols. Fine. Now that's what we have, and therefore we are going to draw on the graph book. So I'll take my ruler. I'm going to use a scale for both axes, 1 centimeter or 1 big square to represent 1 unit for both axes. And therefore, let me start by drawing the x-axis. As the x-axis, indicate that arrow, and also I draw the y-axis. Indicate that arrow, this is the y-axis. So I've said I'm going to use a scale of 1 centimeter to represent 1 unit. So here I have to the negative direction, I have minus 1, from 0, minus 1, minus 2, minus 3, minus 4, minus 5, and so on. To the right direction, positive, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is enough. Then for the y direction, positive y direction, I have 1, 2, 3, 4, 5, 6, 7. That is enough. Then negative y direction, I have minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. That's okay. So from there now, we start with the first one. 3x plus 2y is greater than 4. Here is the table that we came up with for that inequality, and therefore we plot the points first. So when x is minus 2, y is 5. We move up. So that is the point. Then when x is 0, y is 2, to this point there. Then when x is 2, y is minus 1. So that is the point. Then we take the ruler and we draw that line. But we need to be very careful. So, is the line to be drawn dotted or complete line? Since any point on that line is not included. It is greater than. So no points on that particular line should be included. So we are going to draw a dotted line. A dotted line. That is it. And then we are going to that is 3x plus 2y is equal to 4. That is the line. Now we need to find which side of this line satisfy this condition. Which line does it satisfy the condition? So first, we can easily take point near the origin for both x is 0 and y is 0. That's the point near the origin. And if we take that point near the origin, then we substitute into this equation. So 3 times 0 plus 2 y is 0, will it be greater than 0? So we know this will be 0 plus 0, which is 0. So 0 and 4. We know that 0 is less than 4. So 0 cannot be greater than 4. So the side which satisfy the inequality, we are going to shade the unwanted region. So any point below the line does not satisfy what? The inequality. So since 0 cannot be greater than 4, so we shade this region below. That's for the first inequality. We move to the next inequality, which is 2x minus 2y is less or equal to 5. Already we came up with a table which will help us to plot the points. Now let us plot the points. When x is minus 3, y is minus 5.5. Minus 5.5 is in between here. So when x is minus 3, y is minus 5.5. So at that point, when x is 0, y is minus 2.5. Minus 2.5 is exactly at this point there. Then when x is 2, y is minus 0.5. So since one big square represent 1, so this will be represented by a half of it. So here is the point. Then from there we are going to use a straight line to join those points. But we need to ask ourselves from the inequalities. So we have this is less or equal to. So any point on that particular line is included. So we draw a complete line. So we are going to draw a complete line. So we draw a complete line. And this line is 2x minus 2y is equal to 5. So we need now to shade the unwanted region. And in the same case, we can easily pick points above this line. The easiest point is x is 0, y is 0. And therefore, we substitute into this inequality 2x minus 2y is equal to 5 is less or equal to 5. So let us see whether it satisfies these inequalities. Simple. So 2 times 0, then minus. So we end up getting 0 less or equal to 5. So that means 0 is actually less than 5. 0 is actually less than 5. But any point on that particular line is also included. So this is the required region. So the unwanted region is below the line. So we shade this line below. That way. Then, lastly, we have y is equal to 4. Y is equal to 4. We draw the line y is equal to 4. And here is the line y is equal to 4. And since, again, it has less or equal, so we are going to draw a complete line. We draw a complete line. Since any point on that line is also included, so this is the line y is equal to 4. Again, we check points which will satisfy. So I take a point below this line, say 3. I can take a point 3. 3 is actually 3 will be less than 4. 3 will be less than 4, and therefore any point below the line y is equal to 4 is required. So any point above the line is unwanted. So we are going to shade the upper part. And therefore we have this as the required region. That is our required region. So that's how we go about this kind of a question. So thank you so much. See you in our next video.